Now if p is nearly equal to q and n is greater than 1 such that n plus 1p plus n minus 1q upon n minus 1p into n plus 1q is sum p upon q to the power k, we'll have to find the value of k. So what I'll do is I'll start with the left hand side and I'll write it as n plus 1p plus n minus 1q and then n minus 1p n plus 1q. So I'll take these terms of n together. So I can write np plus q plus p minus q. And here also I'll take these terms together. So there'll be n p plus q and then it'll be minus p minus q. So now I'll divide the numerator and denominator with n p plus q. So if I'll divide it, I'll get it as 1 plus 1 by n p minus q upon p plus q. And here I can write it as 1 minus 1 upon n p minus q upon p plus q. Now if I look at this expression, so which is p minus q upon p plus q. Now p and q, they're nearly equal, right? So p is nearly equal to q. So this value is very, very small, nearly equal to 0. So I know that in the binomial expansion of 1 plus x to the power n, 1 plus nx, n minus 1 upon factorial 2x square. Now if x is very small, then I can disregard or discard the higher powers of x. So I can simply approximate it as 1 plus nx. Now when I look at this form, 1 plus 1 upon n, p minus q upon p plus q, I know it is an approximation as 1 plus nx. So I can simply write it as 1 plus p minus q upon p plus q, and this is to the power 1 by n. And also in the denominator, I can write it as 1 minus p minus q upon p plus q to the power 1 by n. Now if I'll simplify, so in the numerator, I'll have this 2p and then p plus q will get cancelled. And here I'll have 2q to the power 1 by n. So so it'll be p upon q to the power 1 by n. So the value of k should be 1 by n.